All right, so there are two special cases when it comes to factoring, and the first one is called a perfect square trinomial. And what the word perfect square refers to is when we do 1 squared, we get 1. 2 squared is 4. 3 squared is 9. 4 squared, 16, etc. These numbers on this side here, we call these numbers perfect squares because they are made from a number that's multiplied by itself. So if I give you a number like 81, you should be able to identify that 81 is a perfect square because we get 81 by multiplying 9 times 9. The format of a perfect square trinomial is that the first term is a square number. The middle term, we write it as 2ab. And then the last term is also a square number. Notice that there are no x's here. When I say a squared, I'm including the x value in that. And when I say 2ab, that's everything that's in the middle term. And b squared also, I'm just counting the last term. So if I look at the example here, a squared would be the 4x squared. 2ab would be equal to 12x, and b squared would be equal to 9. When we factor it, we actually only get a single bracket and it's squared, so we have the same binomial multiplied by itself. And the numbers that go inside is the bases of a squared and b squared. And the operation between them will depend on the sign here. So it'll either be addition or subtraction, depending on whether this is positive or negative. So let's take a look at what that looks like. If I have 4x squared plus 12x plus 9, I'm going to try to rewrite it to look like this above. So I want to write it as a base to the power of 2. So 4x squared, 4 I get by multiplying 2 by itself. So instead of writing 4x squared, I'm going to write 2x to the power of 2. So you'll notice that if I expand this, 2 squared is 4 and x squared is the x squared over here. So all I've done is rewritten it so that I can more easily see what the a value in this case would be. Plus 12x plus, and then the b squared, I'm going to look at it and see, okay, well 9, I can write 9 as 3 squared, so I'm rewriting it as a power, and I'm going to rewrite it as 3 squared. You can have it in brackets if it's easier for you to visualize. So these are my a and my b value. And I can factor it by taking the a value, 2x. I look at the sign here, it's positive, so plus. And then the b value, which is 3. So the a and the b are the bases of these powers. Remember, base is the bigger number, and then the whole thing is squared. And I can check that 2ab gives me the middle term. So 2 times a is 2x and b is 3. So 2 times 2 is 4 times 3 is 12x. And that gives me the middle term, so that means it works. If it hadn't equaled 12, then I wouldn't have been able to use this method. I would needed to have used the factoring complex trinomials method. Okay, let's try one more example like that. Okay, so I notice that I have two square numbers. N squared and 81 is a square number because 9 times 9 is 81. So I'm going to try to rewrite it like I did in the other example. I'm going to try to rewrite it as powers. So n squared, that's already a power, so I can write it like this. You really don't need to write it like this. I'm just doing it that way to help you visualize it. Plus, and then to write this perfect square as a power, well, I get 81 by multiplying 9 times 9, so I'm going to write 9 squared. So this is my A, and this is my B. And I know that when I factor it, it'll be A, the sign is negative, minus B squared. So I can write n minus 9 squared. And I can check 2ab is equal to 2 times n times 9, which gives me 18n. So I'm good. And you don't have to worry about the fact that the sign, that's okay, because the sign is going to work out anyway. Okay. The other type of special case is called difference of squares. So again, squares refers to those numbers like 1, 4, 9, 16, 25. When I say difference, difference means subtract. And you'll notice in the examples, I have two square numbers and they're being subtracted. The general form for difference of squares is that I have a square number and then I subtract a square number. So this is my polynomial that I need to factor. When you factor this, in the other examples, we ended up with a binomial, so two terms to the power of 2. Here, I'm actually going to end up with two binomials, like we did in earlier examples. And I'm going to, in the first set of brackets, I'm going to take these bases, a and b, and I'm going to add them. And then in the second set of brackets, I'm going to take the a and b and I'm going to subtract it. So let's look at this example. Just like in the other example, I'm going to rewrite it as powers and to show what the base is for these square numbers. So I have n squared. That's already the way I need it to look. 9, if I wanted to write 9 as a power, so the number that multiplies by itself to give us 9 is 3. If you're not sure off the top of your head, you could always put it in your calculator. The square root of 9 gives me 3. So that means 3 squared. So following this format, I'm going to have two sets of brackets. In the first one, there's addition. In the second one, there's subtraction. So I'm going to take the bases, the a and the b, and I'm going to say n plus 3, n minus 3. If you can go from this step right away to this one and skip this middle part, that's fine. You don't have to have this part. This is just for me to show you what's happening. Next example. So I have 16x squared minus 4y squared. So square number, square number, square number, square number. So I have a difference, subtraction of squares. If this was a plus sign, I couldn't do this. I wouldn't be able to, the only thing I could do would be to common factor. But in this case, because it's a difference of squares, I can factor more fully. So I'm going to rewrite it by looking at, okay, well, how can I write 16 as something squared? I get 16 by going 4 times 4. So I'm going to say 4x squared. Notice how I put them together so that they're one base. Minus 4 I get by multiplying 2 by itself. And then y squared I get by multiplying y by itself. So I'm going to write it like that. And then again, I'm going to add in the first bracket, subtract in the second bracket. So I'm going to take my a. So in this case, a is 4x and b is 2y. So I'm going to take, the formula tells me a plus b and then a minus b. So I'm going to add them, 4x plus 2y, and then I'm going to subtract them. Oops. 4x minus 2y. And that's my final answer. And if you're ever unsure, you could always use the distributive property and double check to see if that was correct.